Hi guys, welcome back to Unit 2, Lesson 6, Function Analysis, and today we need the strength of Changbin to get us through this because I'm very afraid for this lesson. Just so you know, this not a math person does not refer to him, it refers to me because I am failing constantly. Oh goodness, the cat got on the counter, on the desk, on the counter. Square root functions are, the graph of a square root function is very closely related to the graph of a quadratic function. In fact, taking a square root of a non-negative number is the inverse operation of squaring it. An inverse operation is one that reverses or undoes another operation. For example, the square root of x squared is x. And similarly, the square root of x, when that is in parentheses and it's squared, is still x for non-negative x. If you have a negative x, you can't take the square root of it because that's a not real number. This is just review, and none of this really makes sense to me, like the non-negative x not being a real number, but it's just a math fact, so just accept it and move on. Don't care. Graphically, a quadratic equation is a parabola. The graph of a square root function resembles half of a parabola. Since the negative values under a square root do not result in real numbers, they are excluded from the graph. So there's no negative numbers in the graph, okay? Well, yeah, that I can't really say. You'll see. Example number 1, graph the square root function y equals x. We'll do this together. So, create a table to generate some coordinate points of the function y equals the square root of x. Remember that the value under the square root cannot be negative, so choose x values such that x is greater than or equal to 0. The book uses x equals 0, 1, 2, 3, and 4. So we'll go ahead and do this. This I feel like I can handle. This I feel like, I'm not completely helpless at. So if we have y equals the square root of 0, because that's our first x value, that's the one right here, okay? The square root of 0 is still 0, so y is going to be 0 in that case, and we're looking for coordinate points. So our first one, when x equals 0, then y is going to also equal 0, okay? When x equals 1, we're going to have y is equal to the square root of 1. The square root of 1 is still 1, so y is 1. So when x equals 1, y equals 1, okay? When x equals 2, we have y equals the square root of 2, which is going to be some horrible, awful number. So I'm not going to worry about that for right now. And the square root of 3 is going to be some horrible, awful number. But the square root of 4, when x equals 4, the square root of 4 is going to be 2, okay? So it starts out being this nice straight line, but you can see that it's going to get screwed up because then it goes to 4 and 2. This is what the line is going to end up looking like. So we have 0 and 0, we have 1 and 1, but then it starts going, okay, it starts getting kind of frowny face. So you plot the points. You can see these are those horrible numbers I didn't bother to find. We could have done square root on the calculator, but it's not worth my time. Connect the points with a smooth curve. This is the general shape of all square root functions. You can see if this was a parabola and it continued, it would come down like this, but we're only dealing with half the parabola. Like other functions, these can go through changes. Regardless of those changes, square root functions are curves that are relatively steep on one end, so it's steep right here, and relatively flat on the other. It's flattening out, okay? Now, what you need to know is this is the standard for this formula. This is our standard formula that we're going to deal with for the whole lesson. So this is our basic curve. Later, this curve is going to move up and left and right and down and all sorts of other stuff, but this is our basic curve with the basic formula, okay? I know that much. I figured that much out. Check in. Can a square root function have a minimum value and can it have a maximum value? Okay. Yes, if a is positive, it will have a minimum value because the function increases from the starting point. So we haven't seen an a yet. I don't like it when this book does this. But later we'll have the option of y equals, and there's going to be a number right here, which I'm guessing is the a, times the square root of x. And then they can do like plus or minus, and I'm guessing this one out here will be b. Okay, so when this value is positive, it will have a minimum value because the function increases from the starting point. This would be our minimum value, okay? It is also possible to have a maximum value. If a is negative, the function decreases from the starting point. So if this a is negative, then instead of going up like this, it's going to, like if our a was up here, it would swoop down something like that. Okay? So this is similar to the last lesson. This determines whether or not, in the last lesson it was whether the parabola was up or down. Now it's determining whether it's increasing or decreasing. Okay? Example 2, graph the square root function y equals negative x plus 2, and then outside of the square root is minus 3. Then compare it to the graph of the function y is the square root of x. Okay, so this is our a. That tells us that we're going to be decreasing. Okay, I'm assuming this is our b, and we already know what this one looks like because we have it here that I drew all over. Okay, this is what this one looks like. Okay, we know what that one looks like. So the easiest way for me to do this is to go to GeoGebra. So I'm going to pull that up. Okay, here we are on the GeoGebra site. It's just geogebra.org. Okay, we're going to click Start Calculator. Up here in our little input box, you're going to type y, then hit equals, and we're going to do a negative sign and then this square root button. And our problem is x plus 2. It automatically puts it all underneath that square root. You're going to push the right arrow key on your keyboard to get out from underneath that square root sign. And then you're going to push minus 3. And here is our first curve. Okay, this is what it looks like. I'm just using my mouse wheel to scroll out so you can see that curve. Okay, half a parabola. It's down here. All right. So let's go back over to my slides now. Okay, so they want us to create a table to generate values for the square root function. So the way you would do that is you would just take your values for x. So let's start with x equals 0. It would give us y equals negative square root sign 0 plus 2 and then minus 3 outside of the square root. So that would give us y equals negative the square root of 2 plus minus 3, which, oh, that's an equal sign, sorry. Y equals, let me pull up my calculator and we'll figure out what the square root of 2, even though it's going to be a nasty number. Square root of 2, I didn't do it. Let's go to square root, there we go, 1.414 we'll say. 1.414 minus 3 is then going to give us a y value of, back to the calculator, negative 1.586. Negative 1.586. Okay, you could do this and get more points in order to create it, but again, I showed you how to do it faster on GeoGebra. As long as you know how to do this, you're totally fine to go use GeoGebra. Then you're going to use the same values from example 1 to graph it. So you're going to use the points that you found here. So for example, when x equals 0, then y equals negative 1.58 to create the graph. Okay. And then this is what our graph looks like. This is the graph we just made on GeoGebra. And this is the original graph. Okay. So if we look at this, we can see that both graphs have left endpoints. This is the endpoint for that one. That's the endpoint for that one. Moving from right to left, both functions begin. It's actually from left to right. This book makes mistakes all the time. Moving from left to right, they begin with a relatively steep curve. You can see it's steep, and then it starts to flatten out, and it levels off over towards the right. Okay? So this is what these two look like. Okay, hopefully that made sense. If you need to go back and watch it again, go ahead. You can also graph this line on GeoGebra along with the other one. You would just create a new formula on the same graph and enter the y equals the square root of x, and it will pop this up so you can get this full graph on GeoGebra. All right, a check-in. What would be an appropriate list of x values to choose for the function y equals 2x minus 4, square root of that, plus 1 when generating a table of values, and why? I would have no clue at this point, so I'm guessing you won't either. We'll just go ahead. The table should start at x is negative 2. At x minus 2, I guess, for this function, x must be greater than or equal to 2. And I'm guessing they're getting that from right there. Okay, because that's our x value. Any x value less than 2 will produce a negative under the square root, which results in a non-real number. Okay, so I guess for x values, we're going to start at 2 and go higher. We're going to see if that holds for this. Let's do a little test. Let's say x equals 1. Y equals the square root of 2 times 1 minus 4 plus 1. 2 times 1 is going to give us 2, minus 4 is going to give us negative 2, and you cannot take the square root of a negative number. So that makes sense. Maybe it's based on this number. Maybe we have to have a number that equals at least 0. So 2 times something is going to have to get us to at least 0. That's possible. We'll see if we can figure it out. This one is u. Graph the function y equals negative 2 times the square root of x minus 1 plus 3. Okay, pause the video. You can use GeoGebra. You can do the table. I'll come back and show you how to do it with a table, because that's the way they're doing it in the math book, but you can see GeoGebra is easy. Pause it, go do it, come back. Okay, so if we're going to do this with a table, we need this to at least equal 0. That's what I'm assuming, which means that x needs to be at least 1. Doing x equals 0 isn't going to do us any good. So we're going to start with our table with x being equal to 1. So let's say y equals negative 2 times the square root of 1 minus 1 plus 3. That's going to give us y is equal to negative 2 times the square root of 0 plus 3. The square root of 0 is just 0. Any number times 0 is 0, so this cancels out. So we have y equals 3. So our first point is going to be 1 and 3. Okay, let's do it for x equals 2. I'll erase this so I don't confuse you. I tend to make my math papers very messy because I know what I'm doing, but you probably can't follow my messed up brain. Y is equal to negative 2 times the square root of 2 minus 1 plus 3. So that gives us y is equal to negative 2 times the square root of 1 plus 3. The square root of 1 is just 1. Negative 2 times 1 is just negative 2. So we have negative 2 plus 3, which gives us a positive 1. So when x is 2, y is 1. And you would just continue this for more values like 3, 4, or 5. I don't feel like I need to do that for you. If you need me to do it for you, please comment and tell me that, and I will happily go do that for you. But you're going to come up with all of these points, and then you're going to create a graph based on those points. So our first point is 1, 3, which is going to be 1, 3 right there, and that's our starting point. And our second point is 2, 1, which is, wrong way, which is going to be 2, 1 right there. And we knew that this was going to be a decreasing, okay, because this is negative. So this all makes sense, okay? This has a starting point because anything less than this x equals 1 is going to be a negative number, and it's not going to work because you can't have a negative number under a square root. So there's no points beyond this to the left or higher up, but this goes on forever. That's going to come in later, okay? Question number 2, this is all you. The square root equation, y equals 1/2 times the square root of x plus 4, has been incorrectly graphed. You'll see the graph on the next page. Identify the error and create a correct graph of the equation. Oh, sorry. I have to show you this. Oh, yes. Okay. So this is what the graph looks like. Okay. So there's 2 ways you can do this. You can use GeoGebra and see what the real graph looks like, or you can create a table and see what the graph should look like. Okay. Pause the video, go do it, come back. Okay, I'm going to go ahead and create a table to do this because that's what the book wants you to do. If you don't want to do that, you can just skip ahead. Okay, but we're going to say here, this has to equal at least 0. So x, the lowest value of x is going to be negative 4. Okay, so we're going to say if x equals negative 4, we're going to go y equals 1/2 times the square root of negative 4 plus 4, okay? Negative 4 plus 4 becomes 0. The square root of 0 is 0. Any number times 0 is 0, so it's going to be y. So our first point should be negative 4 and 0. So we should be, on a graph, we should be clear over to 1, 2, 3, 4, and 0. Our first point should be clear over here. So they've got it, they moved it the wrong direction. It should have moved to the left and they moved it to the right. Okay. Let's see if there's any other mistakes. Yep, there, see, it was that easy. That was the only mistake. So we started here with our original graph, which we have on this slide clear back here. Okay, that's what our original graph looks like when nothing else gets messed with. It starts at the prime meridian. And then you can see the slope is different on this one. The slope is lower, it's more like this, but this is also zoomed in further. So, no, it's not. Okay, so they should have shifted this way, and instead they shifted this way. All right, that's all that was on question 2. Okay, this is at the end of your lessons, and it was hard for me because I didn't understand anything that was going on to determine where these should go, so hopefully this is in the right place. So write this answer down, and then at the end of everything you can go enter it into your practice problems. Jonathan graphed a square root function. What is the equation of the function Jonathan graphed? So they want to know what numbers should be right here. So based on what we just discovered, okay, we know that this should be correct because they gave us that information. This number right here is determining the starting point, okay? So if we need x to get to 0, this is saying that the starting point, see if I can figure this out. I'm guessing it's going to be, let me pause. Let's come back and look at this problem. We have 1/2 times x plus 4, and now it's asking us 1/2 times x minus. So when it was plus 4, it got moved the opposite direction. So this one should be minus 4 in order to move that way, based just on this problem. The plus 4 ended up moving the graph, the starting point, into the negatives. So minus 4 is going to end up moving it into the positives. Okay? That's the way my brain works. Practice question number 2. To graph the square root function y equals 1/3 times the square root of x minus 3 plus 2, complete the table of data points for the function. This I can handle. You should be able to handle it too. Pause it, go do it, come back. Okay, so we're going to take y equals 1/3 times x. Oh, sorry, this is my x value that we have. Let's erase that. 3 for this first value, minus 3. This is square rooted, plus 2. So this becomes 0. The square root of 0 is 0. This all cancels out, so y becomes 2. Okay, let's do the next one. We have y is equal to 1/3 times the square root of x, which in this case is 4, minus 3 plus 2. 4 minus 3 is 1. 1 times 1/3 is just 1/3. So we have 1/3 plus 2, which is going to give us 2 and 1/3. So our point here is 2 and 1/3. All right. Let's do the last one. Cha, 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 cha. I love to erase. It makes me happy. All right. And we're going to do 7. So y is equal to 1/3 times the square root of 7 minus 3 plus 2, which is then going to give us y is equal to 1/3. Whoa, that's pretty. Times the square root of 4 plus 2. The square root of 4 is 2, so now we have y equals 1/3. Wow, that's pretty. Times 2 plus 2, So with fractions, we're multiplying straight across. Make this a fraction. 1 times 2 is 2. So 2 over 3 times 1 is 3 plus 2. So our next one is 2/3. Okay, so this slope is going to be, 2/3, not 1, sorry. This slope is going to be really close together on everything, okay? But all it needed us to do was complete the table. So there you go. We are halfway. Quadratic equations with square roots. You have previously solved quadratic equations such as this one, x squared equals 100. And if you solve that, you have to take the square roots of both sides, and you have plus or minus 10. When you take the square root of an answer, you have to include both the positive and negative of that answer, because when a negative number is squared, it becomes positive. So for example, if I take 10 squared, it equals 100 because 10 times 10 is 100. But if I take negative 10 and square it, negative 10 times negative 10 is also 100. So you have to have both positive 10 and negative 10 to have your correct answer. We learned that before, just a refresher. The most basic square root function is f of x is equal to the square root of x. This is the same as y is equal to the square root of x. We're just using function of x instead of y, okay? Don't let it stress you. The graph is shown. This is the exact same graph that we saw at the beginning of the lesson. Notice the following things about the graph. It is an increasing function with no asymptote, and that's because there's not a negative right here, okay? So it has to be positive, and it doesn't ever flatten out. That asymptote means it doesn't ever flatten out or get almost flat. It has no maximum, but it does have a minimum at 0, 0. Right there it stops. It doesn't continue past this point. From the graph, you can observe that the x values of the square root functions must be 0 or positive. Remember that this is due to the fact that the square root function is not defined over negative values. You can't take a negative value and then take the square root of it. The x values or input of a given function are known as the domain of a function. Therefore, the domain of f of x is equal to the square root of x is x must be greater than or equal to 0, which we can see right here. It can't go beyond that. Or in set notation, 0 for x and infinity for y. Okay, so it can't go below below 0 on the x line, but it can go anywhere it wants on the y line. All right. From the graph, you can observe that the y values of the square root function are never negative. So in this particular case, y is not negative. Shoop. The y values, or the output of a given function, are known as the range of the functions. Therefore, the range of f of x is equal to the square root of x is y is greater than or equal to 0 for this one, and y or 0 for x, infinity for y. Okay, we're going to be dealing a lot with these things in this part of the lesson, these ranges. Okay, here's a check-in. Identify the domain and range of f of x is equal to the square root of x. Guess what? That's what we just did over here. So the domain is 0 for x and infinity for y, and the range is 0 for x and infinity for y, because we don't go into the negatives for x or for y.
멤버 중에 Don't make a fuss란 말을 가장 많이 하게 만드는 멤버가 누군지 저희 한 번에 지목을 해볼까요?
이미지상 딱 한 명밖에 없죠.
그렇긴 해.
둘, 셋!
누군데? 나야?
제가 원래 호들갑을 떠는 스타일이 아닙니다. 그러니까 호들갑보다 약간 궁시렁대는 게 많은 것 같아요.
말이 좀 혼잣말을 좀 많이 하게 되는 것 같은데.
서서히 나이를 먹어가면서 혼잣말이 좀 늘긴 해요. 저는 혼자 맨날
It took me half an hour, but I think I've got it now. So, identify the key features of h of x is equal to 2 times the square root of x plus 2 and find the related quadratic. So, the first thing that we need to do is identify, well, here's the graph. Okay, you can make the graph on GeoGebra. But the first thing we need to do, let me erase all of this garbage, is figure out the domain and range. So the domain is the x values, and the way you figure that out is how to make what's here underneath the square root sign, go to 0. So if we have negative 2 plus 2, it's going to be 0. So the domain is negative 2 and infinity, okay? And the range is whatever is outside of this. So sometimes there's a number out here like minus 5 or plus 2 or whatever, and there's nothing out here, so it's just 0 for the range. So 0 and infinity. So this number that's under the square root sign, I'm doing good. It's the opposite of that for the domain, and the number that's outside on the right is the number for the range. Okay? It has no maximum, but the minimum is the number that you got for the domain, which is negative 2, and the number you got for the range, which is 0. So that's how you figure out all of that stuff. Okay? It's just given in the problem. You don't have to do anything fancy, except you need to find what makes this 0. That's the only math you have to do there. Okay, let me erase all of this so that I don't confuse myself or you. Okay, so I found the steps, and I don't know why they didn't just write down the steps for us, because, you know, they have been, but they didn't. The steps are a really helpful thing for me. So we already found out the domain and the range for this. So the first thing you do is you're going to take the whole original problem and you're going to replace the function, the f of x, or whatever they used. In this case, they used h of x, and you're just going to replace it with a simple y and leave everything else the same. Okay, then you're going to swap x and y. That's your first step after that. So replace the function with y, then swap x and y. That's step 2. Okay, the next step after that is to solve for y. Now it gets a little bit tricky here. I kept messing myself up. So in this case, the first thing they did was they tried to get rid of the, I want to call these parentheses, the square root sign. So how you do that is you're going to take everything on this side and square it, and everything on this side and square it. Okay? So when you do that, you're going to end up with x squared right there. 2 squared is 4, and you're going to leave this because all we did was get rid of the square root. Okay, but keep this in parentheses. It makes everything easier later. We're never going to take away this y plus 2. Don't try to do anything with it. Okay, now we need to get rid of this 4, so we divide both sides by 4. Okay, now this is what they're doing here. Another place they like to trick you up. It's not x squared over 4. It's 1/4 times x squared. They do that every time. They get the fraction. Again, parentheses. Why is parentheses my favorite word? They get the fraction and leave the x squared. Okay. Now this and this cancel out, and we have our y plus 2. Okay. Then all they're doing is getting y by itself. Subtract 2 from both sides. Okay. And that leaves us, these cancel, that leaves us with just y, and we have 1/4 times x squared minus 2. Okay, it's written backwards. Usually we see y equals and then this stuff. And so the related quadratic function is, we started out with h of x, and they changed it to k of x to show it that it's a different variation of it. I don't know why. Okay, and I don't know how they pick this letter because it's completely random. But they have, this is the formula that's right here. Okay, so what they do now is they need to factor out this x squared. So this would be x times x, and then normally, so this is what they're factoring out, okay, because the 2 just comes over here. So it would be x, and then normally there's a number right here, but there's not, so it's x and 0 and x and 0, okay. And the reason they want that is so that you can see what your domain and your range are. This is the final form, okay? We're going to keep going. It's okay. I will help you. Don't stress. I finally understand this. So here's question 1. Identify the key features, which is the domain and range of that formula, and find the related quadratic function, okay? If you need help, just keep going. If you think you can do it, pause it, do it, come back, okay? So the domain and range, first the domain is how to make that a 0. So domain, you know, I watched a video and this guy was writing in cursive with his mouse, and I'm like, wow, you do this a lot. I can't write cursive with my normal hand. So the domain has to be They always have a bracket on this side. I don't know why, but -2, because -2 plus 2 is going to give us 0. And then look at my lovely infinity sign. Isn't that pretty? And then they do a parenthesis on that side. And the range is just the number on the right that's outside of, it's not a parenthesis, oh my gosh, outside of the square root sign. So we have bracket, and we have -4, and another infinity sign, and a parenthesis, okay? So there's that and that. Now they want us to find the formula. I'm going to go to a clean slide for that. So the first thing we do is change this to a y. So we have y equals the square root of x plus 2 minus 4. Second step is to switch x and y. So now we have x on the outside, square root, y plus 2 minus 4. Now we're going to solve for y. So the first thing we're going to do before we mess with any of the complicated stuff is move this 4. Okay? We're going to add 4 to both sides. Shoop. That gives us x plus 4 is equal to the square root of y plus 2. Okay? Now we need to get rid of that square root. So this side is going to get squared. And this side is going to get squared. Okay, so we're not going to actually distribute this out. We want to leave it like this. Don't get tripped up there. So we're just going to leave it x plus 4 squared is equal to y plus 2. We're solving for y, so let's get rid of this 2. And that leaves us with x plus 4 squared minus 2 is equal to y. And another way to find the domain and range is to wait until you get to this point. This is the domain, which you can see right back here. Okay, is -4. And this is the range, which is -2. Okay, so this sign got flipped, but that should be your final answer. Let me double check that I did it correctly so I don't screw you up. So x plus 4 squared minus 2. X plus 4 squared minus 2. I did it. Hopefully that made sense. We're going to do another one. See if you can do this one on your own. Do the steps. So first change this to y, then switch x and y, and then solve for y. Okay. And it also wants you to find the domain and range. Pause the video and then come back. I'm going to go ahead and figure out the domain and range first. So the domain is going to be whatever will make this 0, which is just 0 and infinity. This side is a bracket. This side is a parenthesis. And the range is just whatever is outside on the right from the, not a parenthesis, square root. So the range is bracket -5 and infinity with a parenthesis. Okay, let's go figure out our formula. So the first thing to do is change this to y. So y is equal to 3 times the square root of x minus 5. Now we're going to switch x and y, so x goes on the outside. 3 times the square root of y minus 5. Okay, to get y by itself, so let's deal with the simplest, the 5 first. Okay, now we have x plus 5 is equal to 3 times the square root of y. We're going to get rid of the square root by squaring both sides. Choop, choop, choop. Remember, don't distribute here. We're going to keep it x plus 5. Woo, I'm doing good. Squared is equal to 9, because 3 times 3 is 9. 9y. Get y by itself by dividing both sides by 9. And now we have 1/9 times x plus 5 squared is equal to y. Let's see if I did it right. 1/9. I feel like a genius. Yes. Okay, question 1. This one is all you. Identify the key features of z of x is equal to the square root of x plus 2 minus 4 and find the related quadratic function. Pause the video, do it, come back. Domain is whatever makes under the square root sign 0. So it's going to be negative 2 with a bracket and infinity. Oh my gosh, that's beautiful. And range is going to be bracket negative 4, infinity. I feel so smart now. And we're going to solve this. So first change the function into a y. Y is equal to the square root of x plus 2 minus 4. And then we're going to switch x and y. So x is equal to the square root of y plus 2. My pluses are doing well. Get y by itself, deal with the simplest, which is the 4. So now we have x plus 4 is equal to the square root of y plus 2. And we're going to get rid of the square root by squaring both sides. Chonk, chonk, chonk. Okay, don't distribute this. We're going to keep it. X plus 4 squared is equal to y plus 2. Let's get rid of this 2. And that's going to leave us with x plus 4 squared is equal to y. And then they want us to use a different letter. And I remember because I was looking at this and it's stupid, but they decided to use g. So g of x, you don't have to worry about this for the practice and the quick check, it picks for you. But it becomes g of x is equal to x plus 4 squared minus 2. I don't know what happened here, but this was supposed to be a 2. That's beautiful. Let's go double check. G of x, x plus 4 squared minus 2. We did it. Okay, question 2. Identify the key features of 2 times x is equal to 3 times the square root of x minus 5 and find the related quadratic function. I'm going to go double check that I got this right because it's usually like a letter right there. I did have it screwed up. It's w of x. That makes it look a lot more familiar. Pause the video, go do it, come back. So first we'll go and do the domain and range. The domain is whatever makes the number under the square root 0. So it's just 0 and infinity. And the range is whatever on the right of the square root sign. So it's negative 5. And infinity. Wow, that 5 is really pretty. He's gangster. Okay, let's go ahead and solve this. This should be a double. W, ignore that. So change it from a function to a y equals 3 times the square root of x minus 5. Let's deal with the 5. Oh, no, we have to switch first. Watch me, watch me. X is 3 square root of y minus 5. Now we can get rid of the 5. Do the simplest thing first. Now we have x plus 5 is equal to 3 times the square root of y. And we want to get rid of the square root. So we're going to square both sides. Square both sides. Don't distribute it out. It's just x plus 5 squared still. Shoop. Oh, that's a beautiful 2. 3 times 3 is 9. The square root of y. Divide both sides by 9 to get rid of it. And that's going to leave us with 1 over 9 times x plus 5 squared is equal to y. And then they use w, so I'm going to use r of x. I'm sure it's not r, but you know, I can't predict their mood swings. So 1/9 times x plus 5 squared. Let's go check. They used f of x, 1/9 x plus 5 squared. Okay. Now we are moving on to your very end of your lesson. Practice question number 3. In the graph of the square root function y is equal to 3 times the x minus 7, the square root of that, plus 2, what are the coordinates of the point farthest to the left? Okay, so this is one that you don't even have to graph or do anything complicated with. See if you can figure it out and come back. So the farthest to the left should be the opposite of this, which is positive 7, and this normally, which is 2. Okay, and you can double check this by graphing it, or, you know, being smarter than me, which isn't harder to do. Find the related square root function p of x for the quadratic equation h of x is equal to 4x squared with the domain of 0, infinity. Okay, pause the video, figure it out, come back. Alright, so we know our final formula is going to be p of x. I'm going to go ahead and write that down because I'm gonna forget. Okay, so it wants to know the related square root function. We know what the domain is. Okay, so let's come over here. First, we're going to do all our steps. We're going to do y equals 4x squared. Okay, then we're going to switch x and y. So we have x equals 4y squared. I'm not sure this is correct because I don't have any square root signs, which is interesting. I wonder if I'm supposed to do that first. I don't know. Let's try taking 4 away from each side. I'm not sure if I'm doing this right, but we'll find out. That would make this 1/4 x is equal to y squared. And we want y by itself, so we're going to have to take the square root. I have no idea what the square root of 1/4 is. Calculator time. 0.25, and let's hit the square root button. Is 0.5. Okay, so this becomes 1/2 x is equal to y, and I'm not sure what the domain has to do with that. If the domain is 0, yeah, I don't know. I'm guessing this is 1/2 x. Give it a shot. If it's wrong, let me know and I will make another video and come back. I hate when they do this. They didn't do anything like this in the whole lesson. But here, you guys figure it out. I'd be more concerned, but you don't get graded on the practices. So consider the quadratic function that represents the inverse of the graphed square root function. What would be the vertex of the related quadratic function? So the vertex, this is going to go on forever. So normally I would think that the vertex is the highest point, but guess what? It can't be because we don't know where it goes. So if this was a parabola and it was shaped like this, then this would be the vertex. So I'm assuming that the vertex is at 7 and 3, because I don't know why they would make it more complicated than that. So we're going to say 7, 3. Here's your quick check questions. These you do on your own. I guess you've been doing everything on your own, so what's the difference? What is the ordered pair of the end point in the standard form of the square root function y equals 5 times the square root of x minus 4 minus 1? So remember, the end point is the beginning point, and it's going to be written right here in your formula. So one of these is x, one of these is y, and you have to do something here. I will give you that much of a hint. Quick check question number 2. Rihanna grabbed a square root function. What is the equation? Graphed. She didn't grab. Wow. What is the equation of the function she graphed? So you're trying to figure out which of these is the correct equation for this. Okay. Quick check question 3. Given the square root function y equals 1/2 times the square root of x plus 3 minus 9, what is the y value when x equals negative 13? The way I would do this is I would take this x value and plug it in right there and solve for y. Now, that's not guaranteed to be right because I am me, but that's what I would do. Quick check question number 4. Which of the following correctly identifies the quadratic function that is related to the square root function k of x is equal to 5 times the square root of x? So you're going to take this and do all of our steps, change this to y, switch x and y, even though there's not a y. Wow, okay, yeah, good luck with that one. Quick check question number 5. What is the vertex of the quadratic function that is related to the square root function of the graph? That was the very last problem that we did right here. So I'll go back and give you a look at that. The vertex is not the highest point up here. It's where the parabola would be if you had the other half of the parabola. So go ahead and figure that one out. And when I finished this, I named the slide I'm scared for this lesson, and please help me because I knew this was going to be difficult. But you know what? We didn't have any major screw-ups. There should have been a Changbin picture in the middle of it all, but because I had to stop and take a half-hour break, I mean, that's a pretty big screw-up. That's the worst screw-up I've had. But honestly, it kind of went better than it did. Peace out, guys.